This is the seventh video in a series of what I expect to be about 20 or 30 videos taking you from kindergarten through high school math. And up until now, we've seen the basics of adding, subtracting, multiplying, and dividing, fractions, decimals, percentages. But I wanted to take this video, before I start getting into the middle school, I wanted to do one video here, which will finish out the elementary school math, and also something that hasn't been talked about yet is that math is more than just adding, subtracting, multiplying, and dividing. There was a book, I think it was called The Mathematician's Lament, and it was about how elementary school math and high school, the school math misses like the point of math, which is like the beauty and the thought process. And this guy, Paul Lockhart, compared the way math is taught now to like a world where kids learn music for 12 years, but they learn like all the music theory, but they never actually get to listen to a song. And in math, there needs to be some opportunities to like mess around, figure things out, and see how like math is interesting. Negative numbers. So I'm going to talk about negative numbers and then a couple of like thought-provoking problems that give students like a taste of what mathematicians do and why people like math. But first, I want to say something about negative numbers. So if you do 5 minus 2, you get 3. But if you do 2 minus 5, well, we have a problem because 5 is bigger than 2. But if we allow ourselves to have negative numbers, and I like to think of this, there's different ways to visualize negative numbers, but I like to think of it as if I'm like 2 feet above ground, here I am up here, and I want to go down by 5 feet. Well, actually, this is pretty good. It's a pool. So I'm 2 feet above the water here. It's better than ground. I really should plan this stuff out ahead of time. So when I go down 2 feet from where I am, I'm on the surface of the water. But if I go down 5 feet, I have to go down 2 feet, and then down 3 more feet, and that's a total of going down by 5 feet. But I end up down here at 3 feet below the surface of the water. And 2 minus 5 is not 3, and it's not impossible, but it is negative 3. And that's what happens with negative numbers. Now, if I'm here at negative 3, and I go up 4 feet, well, then the first 3 feet get me back to the surface, and the fourth foot gets me 1 above the surface. So negative 3 plus 4 is 1, and it's the same thing as 4 minus 3. And 2 minus 5 from before is the same number as 5 minus 2, except it's negative instead of positive. Sometimes when I think of combining integers or combining numbers, positives and negatives, it's almost like these two numbers are like fighting each other. The minus 2 and the plus 2 and the minus 5 are like fighting each other. Well, the minus 5 is like the bigger number, so he's going to win the fight, and that's why it's negative. But the plus 2 kind of like causes the minus 5 to get like weaker, so he's down to negative 3. And here it's like the negative 3, and even though this is a plus sign, I'm going to think of it as positive. When negative 3 and plus 4 like fight each other, the 4 is more powerful, so he's going to win, and that's why it's plus 1. But in doing so, the minus 3 kind of like steals some of the plus 4's power. These two situations are done with subtraction. Remember when I was down here at negative 3? If I take away 2 from negative 3, I go down even further. and I end up at negative 5. So minus 3 minus 2 is not negative 1, as some people think when they first look at it, but it's negative 5. In this case, these two things are both negative. So they're on the same team. They're not fighting each other. So together, they become a negative 5. And just to round this out, minus 8 plus 3. This is I'm all the way down here at minus 8, and I want to swim up by 3 feet. Well, I don't make it to the surface. I only make it to negative 5. So when you do minus 8 plus 3, kind of like this one, minus 3 plus 4, we end up subtracting 8 minus 3 is 5, but it's negative 5 because, again, the minus 8 is bigger than the plus 3, so the answer is going to be negative. So a lot of these questions are, plus 2 minus 5, or minus 3 plus 4, or minus 8 plus 3. If the two signs are different, we end up subtracting the two numbers and taking, as we say, the sign of the one that's bigger. But if the signs are the same, like minus 3 minus 2, you get negative 5. And that's the main. Now, there's more situations besides diving into a pool. We could have, money in the bank, or maybe I have $10 in the bank, and if I buy something for $30, well, now my bank account would be negative 20. They used to say this is the reason why we need to learn negative numbers, that you have like a ledger, with debits and credits, and then we do minus 30, and we end up down here at minus 20. It's not really very inspiring reason to tell kids you want to know about negative numbers. Hopefully, if you have a bank account, you don't ever go into negative numbers. Multiplying 5 times negative 2, well, 5 times something is the same thing as it sort of being added to itself 5 times. And minus 2 plus minus 2 plus minus 2 plus minus, that's a lot of negatives being added together. So it's negative 10. And you multiply a positive times a negative by multiplying the numbers together, and the answer is going to be negative. But one of the strange things in math is that a negative times a negative is positive, which seems really weird. Why isn't it extra negative? One reason that I like, that I've read about, there's different explanations for this. I once saw a nice example where someone puts money into the bank, or in this case, under their mattress. So every week, I got this from a book called Beyond Numeracy by John Allen Paulos. So somebody puts $10 under their mattress every week. So in 5 weeks, 10 times 5, they'll have $50 under the mattress. So that's positive times positive. Now, they start taking money out of the mattress, $10 a week, minus $10. So minus $10 times 2 weeks, they'll have $20 less. That's negative times positive is negative. And now, let's go back to the place where I had, hold on. Let me say it this way. It's a little confusing, this one. Let's say I have $100 in there already. And I'm taking out $10 a week. So in 3 weeks, I'll take out $30, and I'll be down to $70. Now, that's 3 weeks from now, I'll have $70 less. But if I want to go sort of back in time, what happened 3 weeks before? Let's go back to our $100 situation. I've been taking out money for a while, and I have $100 in there at this point. So minus 10, if I go back in time 3 weeks, well, I'll actually have more money in there. I'd have $130 in the bank. Again, this is a real informal explanation. I've seen all kinds of explanations where people talk about a number line and 5 times -1 is -5, so that multiplying by -1, flips it this way, and then multiplying -5 times -1 again. I don't find that so compelling. Now, I've even seen some real formal explanations of why -1 times -1 has to be +1, where they do some kind of real confusing, mental sort of gymnastics, where they do something like that, and they distribute the -1 through. Anyway, I don't even want to get into that. Negative times negative is positive. It's a pretty confusing thing, and it's a point in math where a lot of people sort of give up on trying to understand things. This mattress example is not the most clear explanation, but I want to show you it anyway, because I remember reading it and liking that. So with negative numbers, together with the adding, subtracting, multiplying, dividing, decimals, fractions, and percents that have already happened, we kind of have all the math from kindergarten up until about 6th grade. But what we haven't seen, like Paul Lockhart says, kids learning music without ever hearing a song, they're not going to like music very much. They're not going to get very good at it. So is there some kind of fun, problem solving? I'm just call it problem solving. We tell students, oh, you're going to want to learn math so you can manage your money. But what math do you really need to manage your money besides adding, subtracting, multiplying, and dividing? It doesn't seem like a good enough reason to study math for 12 years. Maybe it's good enough, like in the olden days, in the 1700s, where if you stopped learning math after, 4th or 5th grade, and you had enough math that you needed for your life. To get students to really like math, you want to give them some interesting problems to think about, thought-provoking problems. One example of a fun problem, I think, is this one. MM plus NN equals TNT. So in this kind of riddle, the n's represent digits. So NN is maybe it's 11, maybe it's 22, maybe it's 33. And the MM, those are 2 different digits. I like this. It's just a fun thing. You should pause the video, just mess around with it for a bit. Okay, I'm going to give the answer now, so if you didn't pause it and think about it, you've missed. Once you see this, you can't unsee it, so you'll miss the opportunity to have a little bit of fun. The first observation is that T is going to be the number 1, because MM at most is 99, and NN at most, NN's going to be at most 99 also, although if MM's 99, NN's going to be at most 88. Either way, these 2 things add up to less than 200. So those things have to add up to 1. Now, so M plus N, well, M plus N can't equal 1 though, because it's if m plus n really equaled 1, m and n would have to be 0 and 1, and mn plus nn would just add up to 11. So m plus n has to add up to 11, which means there has to be a little carry of the 1 here. But then we have m plus n plus 1 with the carry. So m plus n plus 1 has to be 12. And that's why n has to be the number 2. So nn has to be 22. But then if m plus n is 11, then m has to be 9. And the answer is 99 plus 22 equals 121. That's not an important question in the sense that it's not a life skill, but it's like a riddle, and it's like a jigsaw puzzle or Rubik's Cube. It's just like a fun riddle. I'll leave you with another one, which is much harder, which is send plus more equals money. It has similar logic to it. So that's like a fun problem. Other fun problems. I mean, I'm a big fan of this thing, the 4 fours problem. You write 4, 4, 4, 4 equals 0. 4, 4, 4, 4 equals 1. 4, 4, 4, 4 equals 2. And you try to add like pluses and minuses and parentheses or whatever else. Like this one could be 4 minus 4 plus 4 minus 4 is 0. And this could be like 4 plus 4 divided by 4 plus 4. And this one could be 4 divided by 4. That's 1. Plus another 4 divided by 4. Anyway, you can mess around with that and see how many of the numbers you can make. That's called the 4 fours riddle. So there's send more money. There's the 4 riddles. I personally like this sort of a geometrical problem. In this riddle, the 9 dots problem, you're trying to make 4 lines. Once you start writing, you can't lift your pencil or trace over, and you're trying to go through all 9 dots. So maybe someone goes like 1, 2, 3, 4, but they missed a dot. Maybe they try to go like 1, 2, 3, 4. Again, they missed a dot. I'm going to give the answer, so you might want to pause now, because, again, I'm only going to show like 4 or 5 riddles. You'll never unsee this one once you see it, so pause. Okay, I'm giving away the answer. The trick to this, it requires a little bit of out-of-the-box thinking. If I go up beyond the box, and then come diagonally, and then go across, and then back up. Anyway, that's the answer to the 9 dots problem. Another fun riddle is to try to draw this house thing. Is it possible to draw this house without tracing over the same line twice? Why don't you mess around with that? Okay, welcome back. So there are several ways to do it, but all of them start either in this corner or in that corner. And if you start in the proper place, you can probably do it. So I started here and ended here. But if you don't start, so I started on the blue and ended in the green, or if you start in the green and end in the blue, but if you try to start in any of the other places, you'll get stuck. And it's related to a very sophisticated type of math called graph theory, but that's a riddle I like also. There are a lot of books of these riddles, and a lot of them are written by someone named Martin Gardner. I like those. A really difficult riddle is the 100 locker problem. And I'm showing you these 4 or 5 riddles just to show you that there are hundreds of riddles of this sort, and they make you think, and you get like they give you such like when you have like an insight, like a moment where you're like, wait, maybe this would do it, and then it works, or it doesn't, and it's frustrating, but then eventually you get it. You get a feeling of satisfaction, and I like to think that in math, that's why we learn math, because people have enjoy that satisfaction so much that they made it, a thing that we study for 12 years. But if we don't get opportunities to have those aha moments, then, are we really doing anything, that useful? The 100 locker problem is actually really hard. The way it works is there's a school that's got 100 lockers, and they're numbered 1, 2, 3, all the way up to 100. And there's 100 kids. And the first kid comes, and they open up. So all the lockers are closed to begin with. I'll put a C for closed. And kid number 1 comes and opens up every single locker. And kid number 2 comes, and they go to every other locker, every multiple of 2, and they switch it. So if it's open, they close it. Well, they're all open. But now, after kid number 2 comes through, all the even lockers are closed. Now the third kid comes, and they will interact with every multiple of 3. So they're going to change. If it's open, they're going to change it to close. If it's already closed, they're going to change it to open. And this is going to go on and on until there's 100, until all 100 kids come. Now the 100th kid is only going to deal with locker number 100, because every kid deals with multiples of whatever number he is or she is. Probably he, because who else is going to be messing around with all these lockers? Now, I'm just joking. Girls can misbehave just as much as boys can. So the question is, when the 100th kid finishes, which lockers exactly are open and which are closed? Now, this is a riddle that you spend like an hour thinking about. So if you want to pause and mess around with it, but then I'll show you the answer. So there are so many ways to do this riddle. One way is to simulate it, to just like write out at least like the first 10 numbers and see what happens and see if you notice anything interesting about which lockers end up open or closed. If there were just 10 kids and 10 lockers, that's a good strategy. But the trick is to this riddle is to look at an individual thing and say, who interacts with locker number 1? Well, just kid number 1. That's it. Once kid number 1 opens it, well, it starts there. They're all closed. So kid number 1 opens it. There's no one else that's going to touch that locker. So locker number 1 is going to end up open at the end. Locker number 2, on the other hand, kid number 1 touches locker 2, because 2 is a multiple of 1, and kid number 2 touches locker 2. But no one else does, because the other kids start at locker 3 or 4. So only 2 kids touch locker 2. The first kid opens it, the second kid closes it. So locker 2 will end up closed at the very end. Now who touches locker 3? Kid 1 and kid 3, because those are the only numbers that are what we call factors of 3. Anyone bigger than 3 is going to start at that locker, and kid 2 skips over locker 3. So since there's 2 things here, it's going to end up closed. But 4 is touched by 3 kids. kid number 1, 2, and 4, those are all factors of, those are the factors of 4. Kid number 1 opens it, kid number 2 closes it, kid number 4 opens it, so it ends up open. And locker 5 is only touched by 1 and 5. So the thing is that determines whether it's touched, whether it's open or closed, is whether there's an odd number of people that touch it. See, this is 3 people, so that's odd. Well, these other ones are even. If an even number of people touch the locker, first person opens it, the second person closes it. If it keeps going, the third person opens it, the fourth person closes it. So now the question becomes, which numbers have an odd number of factors? Well, the number 6 has 1, 2, 3, 6. That's an even number of factors. The number 7 is 1 and 7. That's a prime number. It's 2 factors. The number 8 is 1, 2, 4, 8. That's even. It seems like most numbers have an even number of factors. And the reason that happens is because when you take 8 and you think, what makes 8? 1 times 8, 2 times 4. See, they come in pairs. The number 10 is 1 times 10 and 2 times 5. So there's 4 factors. So those all end up closed. But I left off 9. 9's factors are 1, 3, and 9. So there's only 3 factors. So that one ends up open. So now it seems kind of random. Most numbers seem to have an even number of factors, but occasionally there's one with an odd number of factors. So now the big question, what's so special about 9 and 4 and 1? Well, when you list out the factors of 9, you get 1 times 9 and 3 times 3. Ooh. It's not even because the 3 times 3 is just one thing. It's just the number 3. Well, when does that happen? When is my list of like things multiplied together have on it something like this? Only in a very special case. Only for the numbers 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. Those numbers are known as the perfect squares. 4 times 4 is 16. 5 times 5 is 21. It's 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. And 10 times 10 is 100. These are the only 10 lockers that will end up open at the end. Take 64 if you want. It's 1 times 64, 2 times 32. See, they're all coming in pairs, 4 times 16. But then the 8 times 8 ends up in the middle. That's why 64 has 1, 2, 3, 4, 5, 6, 7 factors, odd number of factors. Open, close, open, close, open, close. Whoops. Open, close, open, close, open, close, open. It ends up open at the end. Only these 10 lockers ends up open. The other 90 ends up closed. Anyway, that's a really hard riddle, but it involves elementary math, just like odd numbers, odds and evens, factors, perfect square numbers, like 5 times 5, 6 times 6. I really love that riddle. There are plenty of other riddles. There are geometric riddles, there are numerical riddles, there are logic riddles. I'll just give you one last one, from a Martin Gardner book. I particularly like this one. The way it works is someone has 3 steaks. And the way these steaks are on a barbecue grill, we have to cook them 10 minutes on each side. And the barbecue is only big enough to fit 2 steaks at a time. That looks like an alien. Now it looks like steaks. So the question is, how long will it take you to cook the 3 steaks? What's the minimum amount of time it would take you to do the 3 steaks? Why don't you take a minute to pause and ponder that question? Okay, welcome back. If you said 40 minutes, you would not be correct. So it seems like, let's call the steaks A, B, and C. It seems like, and I'll call the front, I'll go, if you do A front and B front for the first 10 minutes, and for the next 10 minutes you do A back and B back, and then for the next 2 minutes you do C front, and for the next 10 minutes you do C back, it would seem to be 40 minutes. But the answer is not 40 minutes. If you thought it was 40 minutes, why don't you pause again? Because I'm going to give it away. And once you see the answer, you can't unsee it. You'll know the out-of-the-box answer for the rest of your life. So you'll never be able to re-experience this. So pause again. Okay, welcome back. So the answer is, if you do A front and B front first, and then you do A back and C front, you now have, there's 6 sides altogether that need to be done. But now, I can do B back, because A's done now, and now I can do B back and C back. And I can actually accomplish it in 30 minutes. And that's a great riddle. See, these things are like, they're fun, they're challenging. It's not practical. No one's actually going to be a better barbecuer because they can figure out this riddle. It has nothing to do with the real life. It's about how clever can you be and how logical can you be, and can you think of doing things? Is there more than one way to do something? I think that's why math has endured as a thing, but even though we hardly ever teach these things, I think that without this, math, it can't just be because it's good for our checkbooks and one day we'll have negative numbers because we spent more money than we had in the bank. We should be teaching people never to spend more money than they have. And if that's the case, they wouldn't need negative numbers if that was the only use of them. So riddles like this are the sorts of things that make mathematicians excited. I just have so many more. I could probably make an entire series. I'll give you one more. You could stop watching the video if this is too many riddles for you, and you could skip to. I'm getting into algebra in the next video, so getting into like 7th grade math. But this is such a good riddle. Also, it's actually a very famous riddle. The jugs and water problem. In the movie Die Hard 3, they had to do this riddle. You have these 2 like jugs of empty jugs. One can hold 5 gallons, and the smaller one can hold 3 gallons. And you have an unlimited water supply. And the goal is to get exactly 4 gallons of water into the 5-gallon jug. And it's hard because there's no markings on these jugs, and you can't like just approximate. So some people say, well, I'll fill the 3. Here, I'll make a little chart here, 3, 5. So I fill the 3. Wait, we start with not 0 and 0. I fill the 3 and pour the 3 into the 5. And then I fill up, 1 jug into the 3 and pour it into the 5. Well, the problem is how do I really know that it's exactly 1? Yet it is possible. There's actually 2 ways to do this problem. Why don't you pause? This is my last riddle. I could do this for 4 or 5 hours. This is the last one. The video will be 40 minutes long. How can you do it? And then I'll show you an answer in a few seconds. So pause now. Otherwise, again, you'll never unsee this. Okay, welcome back. So one solution is to fill the 3, pour the 3 into the 5, fill the 3 again, pour the 3 into the 5. Well, when you do that, the 5 gets full, and the 3 has 1 left in it. Now that one's interesting because I managed to get it. Now you can dump out the 5, pour the 1 gallon from the 3 into the 5, fill the 3, and then pour it, and then finally pour the 3 from the 3 into the 1 that's already there for the 5 to get 4. That's one way to do this riddle. There's another way. You want to pause and try to figure out the other way? Okay, the other way is to start by filling the 5. Then you dump the 5 as much as you can into the 3, and you have 2 there. So 2, that's a new number. Dump out the 3, pour the 2 from the 5 into the 3. Now this one has a sneaky finish. Fill the 5, and check out this clever last step. Take the 5 and pour it into the 3 until the 3 gets full. It gets full very quickly because there's only 1 gallon left to fill it. And you'd have 4. So those are the 2 ways. Anyway, the reason I showed you this video today, even though the only math skill was the positive negative numbers, if you don't include into math some fun, some riddles, some opportunity to mess around and figure things out, people might get good at math, but they're not going to really enjoy it or want to do it. And also, these riddles, to me, prove a point that math, if you just try to show that it's practical and that you balance your checkbook with it, that's not going to be enough to get people to want to do it. Because it's kind of a lie. Math, yes, it's important to be able to add or subtract, but not 12 years of math worth. It's true, higher math gets used in sciences, and that's important. But if you want to keep kids interested in math, there should be opportunities for them to mess around with problems and fiddle around with them. So getting some books, some Martin Gardner books, or if you go into Amazon, not to advertise for them, but if you look up Martin Gardner, and people who bought Martin Gardner books also bought, there's a lot of logic books by this guy, Raymond Smullyan. Anyway, try to have some fun, just like if you're learning music, you got to play some songs once in a while. Those songs are not, in math, are not just like balancing your checkbook. The songs are like fun riddles. So look for opportunity. I showed you a bunch of them. I showed you 1, 2, 3, 4, 5, 6, 7, 8. That's actually a lot of riddles to show you. Okay, I promise you, if you just want the math skills, next video we start getting into algebra. See you next time.